To get a better understanding of what happens to our voltages and currents in an AC circuit, let's take a look at a simple one that just has resistive elements. So we have a 1K source right here, 1 kilohertz source with a 1K resistor and a 1K resistor. And let's examine the voltage and current over time that passes through this junction here. So what we will be measuring is the voltage across this resistor and the current flowing through both resistors. And so when we look at our plot over time, because we're considering power, power is always voltage times current, and we can see that our voltage and current curves are aligned at the same point in time. So when the voltage is very positive, the current is very positive, and when the voltage is very negative, the current is very negative. So if you're looking at the power of all of this, the power is maximized at the same time because the voltage and current are in phase. But now let's take a look at this circuit and see what happens if we replace this resistor with an inductor. And so we take out the resistor and let's put in a 1 millihenry inductor. And again, because our inductors have an impedance that is JWL, that's based on the frequency, and because our inductors build up a magnetic field inside of them, they will actually impede the flow of current through the circuit. And so again, as we go back here and we go to plot the voltage and current through the inductor, what we're going to see is that these two items are no longer in phase, that our voltage peaks come well before our current peaks. So our voltage peak is right here at about 1 millisecond, whereas our next current peak is at about 1.2 milliseconds. So what that means is if I'm a particular electronic device and I need, let's say, 5 millivolts to run, at that time, I actually may not have sufficient current. So right here at this peak, the current is actually 0. And so if I need a full 1 milliamp to operate, I have to wait until the next peak, but then my voltage may be too low. And so what happens is that because the voltage and current are out of phase, certain devices may have sufficient voltage to begin operating, but then there's not enough current supply. Or at the times where there's a lot of current supply, the voltage potential is not there for the device to begin operating. And for things like electric motors, this can cause a lot of inefficiencies and overwork the systems, and they may not even operate. So fundamentally, by having resistive elements and inductive elements in a circuit, we are going to make our voltages and our currents become out of phase within our circuit. And what we'll study in AC circuits is how to calculate how much they're out of phase and then what we could do to actually compensate